Okay, in the point A, they ask us to write the position equation from the baseball helmet. We had the formula, and the formula is y. It's equal to initial y plus initial velocity plus acceleration. And acceleration is a constant, and it's always gonna be minus 9.81 times time squared over 2. Then we substitute the values with the velocity and the y, the initial y, and with the acceleration. But we have to find time.
Ask us for find the equation of the velocity for the helmet, for the baseball helmet using the derivative definition with liquids. Well, the primal f of x is equal limit h approach 0 is equal to f of x plus h minus f of x over all over h. Well, this is the derivative definition with limits, because f primal of x is equal to b of x, the final velocity of x. Well, we substitute and multiply the t's and the h, so we can eliminate some terms, because the addition or the subtraction goes to 0, so like minus 4.9 t squared and 4.9. So after all the procedure that we did, we obtained that the result that is f of x plus h minus f of x all over h, and this is the equation. Then after substitute and do all the necessary operations, so we need this over h, but if we substitute, h is 0, so all the equation is going to be 0. So we to eliminate h, we do this, that is putting 1 by 1 over h. So we eliminate this h and this square and this h, so this is going to be 0, and that is, here is the expression, minus 9.81 time minus 0, because for this is 0, and plus 27.43, that is equal to f primal of t. The point C ask us for search, or more like explain why this velocity is important. So this velocity is important because first, f primal of x is equal to b velocity of x. So we can, to calculate the time, we can equal b to 0 and isolate time. So we did it, and the time did the division, and the time is 2.
So now we have the whole values to use this formula. So we can put everything in the formula, and then we can have y, and y is 251.54 meters.
So we use the general formula from the first equation that was in the point A. So this is the general formula, and the x that results, it's x1, is equal to minus 4.36, but it's negative, so we can't use it. And the second one is x2 equal 9.95, so we can use this is the formula, and we substitute, and the final velocity of the whole problem is 70.17 meters.
In the point D, they ask us which one is the acceleration after 2 seconds? The acceleration is minus 9.81 meters per square second, because the acceleration is not changing in any cases, because acceleration is a constant value. Okay, with this problem we learn how to calculate the velocity, and also we learn how to calculate something just having a part of it, like for example the final y only having the initial one. We know now that we can use this type of problems in the real life just for knowing a part of something or to complete